Good day. For those of you who do not know us, we're the instructional staff for ECE 150, Professors Hiren Patel and Werner Dietl, and Douglas Harder. In this topic, we're going to describe some compile time errors. So in this lesson, we will define compile time errors, and then we will look at different examples where mistakes in coding resulted in compile time errors, and also how to fix those. Now, sometimes in English, you can say something completely wrong, but the person listening to you can interpolate and determine what you actually meant, perhaps based on context or tone. Such as, for example, "Oh, whatever you do, bring back some Karl from Iceland." And no matter how interesting it tastes, the other person probably realized you meant, "Don't bring back any Karl from Iceland." Although, sometimes you're unlucky and they'll actually misunderstand you, or they'll take your words literally and bring you back 3 or 4 packages thereof. In which case, send some to me. The compiler is not so forgiving. If you enter C++ code that does not make sense within the C++ programming language, the compiler will simply tell you. Now, fortunately, as compilers get more advanced, they will often try to give you messages that try to tell you or help you understand what it is confused about. Sometimes these messages are useful, other times not so much so, based on how egregious your C++ code actually is. The thing that the compiler will never do is it will never make assumptions about what you meant. After all, if you guess wrong, you may actually have firmware on your pacemaker malfunctioning, and that would be catastrophic. So, what we're going to do is we are going to take code that works and then introduce errors to see how the compiler responds. Now, very important, the response of every single compiler is going to change from compiler to compiler and even version to version. Newer and newer versions of compilers give better messages, but these messages are nevertheless going to change. So do not memorize the error messages. Instead, learn how to read them. Alright, we're going to make changes just to the first line. So we're just going to introduce mistakes either in the spelling of include or IOStream, forget the pound symbol, etc., etc. And we have made all of these mistakes lots of times. In this first example, we're going to forget to include the pound symbol in front of the include directive. Now, when there is an error in your code, a lot of information is actually provided by the compiler. Let's take a look at that first warning or error message. It tells you which file the error is in, or where it believes the error is in. It also tells you which line within that file the error is apparently at, and it tells you which character within that line the error is at. It then prints that line to the screen and includes a caret to point out that first offending character that is causing the problem for the compiler. Alright, so here we see not just one error message, we actually see a number of error messages. Always look at the first error message and only the first error message. Forget everything else. And if we take a look at this, the compiler is saying, oh, wait a second, I've got an identifier here, but include does not name a type. So the only thing that you could actually put here if you had an identifier is a type name, such as int or double. But include is not a type, so that's what it's indicating. Every other error is a consequence of not including the IOStream library. So if you fix that one mistake, all the other error messages disappear. So with so many error messages, you may think you've actually committed a cardinal sin and you have no clue how to program. But don't worry. Very often, fixing the first error will eliminate many of the other subsequent errors. You will definitely, within this course, produce at least one mistake that will have 5 or 6 screens of error messages appearing. Just take a breath and take a look at that first error message. In this case, if we misspell the word include, then the error message is quite straightforward. This is an invalid pre-processing directive. You'd think it suggests that you probably meant include, but it's just pointing out, I don't know what this directive means, please fix it. Now, if we forget to include the opening angled bracket in the include directive, then the error message is actually very clear. The error message says the include directive expects either a file name in double quotes or a file name in angled brackets. If we misspell IOStream, it's quite clear. The file is not found. There is no file called IOStream. So if it can't find that file, then you've probably misspelt it. If you forget the closing angled bracket, at the very least, the compiler is actually very nice. It tells you, look, we're missing a terminating angled bracket here. Please add it in. So this is about as clear as you can get. Suppose that you forget that the type is int and instead use the full word integer. So integer main. Well, the error message is reasonably clear. It says, error, integer does not name a type. And it's important to see that once again, the error message is in the file example.cpp on line 4, starting in with the first character. Now, some programming languages use a capitalized main function. So suppose you forget you were using C++ and instead you reverted to using main with a capital M. And C++ is case sensitive. The error message is unclear, but the point is made. There's that phrase there that says undefined reference to main, meaning the lowercase version. The problem with our compilation is the actual file is fine. Main is a perfectly good function, but it's not the one that C++ is going to be executing when launching a program. However, in reality, if you actually do name a function main with a capital M and intend to use it as a separate function from the main function, then perhaps you're in a state of sin. Now, let's suppose that you forgot the semicolon after the function declaration of mySign. Forgetting semicolons is very common, especially for more novice programmers, but we make those mistakes as well from time to time. The error message, however, is less clear. The error message does not point to the line missing the semicolon. It points to the start of the line, line 8, where int main is defined. The problem here is, because there's no closing semicolon, it's treating the function declaration and the function definition as a single statement. So it's trying to interpret this bizarre expression here where we have double with one function, name and parameter, and a second function with its return type. This doesn't make sense. So it's pointing out the int after the function mySign shouldn't probably be there. Now, suppose you forget the std double colon in front of cout and end of line. Well, the compiler actually does make some suggestions. First of all, it tells you that cout was not declared in this scope. And then it gives you a note. Here's a suggested alternative. How about using stt double colon cout? Okay, that was a little bit more useful, but there's a lot of extra information there, but nevertheless, the suggestion is indeed there. Suppose that we forget an opening quote to the string hello world. The first thing the compiler points out is that we're missing a terminating double quote. We have an opening quote, we need a double quote, we need a closing double quote on the same line. But the compiler nevertheless tries to carry on because it's also saying, well, it's trying to interpret hello as if it was, say, for example, the name of a function or a variable. And it's saying hello was not declared in this scope. Also, it's trying to interpret world as another function name or variable name, or perhaps even a type name. And it's saying, look, you already have the identifier hello. You better have a semicolon or perhaps some sort of operator between hello and world. Now, here we see the compiler trying to make sense of your mistake. But if you fix the first mistake, that is, putting in the double quote, then that will solve all the other mistakes as well. But at least we can see how the compiler is trying to make sense of what's being presented to it. Now, if you forget to include the closing double quote, so closing the string, then as far as the compiler is concerned, everything after the opening double quote is a string. So there's nothing to misinterpret. The only issue is that we're missing a terminating double quote character. Okay, this error message is a little bit more straightforward. Now, if you forget the closing quote here, then we have a different issue because the line has two strings on it. So essentially, what's happening here is that it's interpreting all of these characters as a first string. It then tells you, oh, wait a second, I have an opening double quote here, but there's a missing closing double quote. And between these two strings is an exclamation mark. Well, actually, the exclamation mark in C++ is a unary operator. And for any of this to make sense, there actually has to be a semicolon before the exclamation mark. So there must actually be a semicolon between the string that it sees there and the exclamation mark. So all of these error messages are sort of described here, but overall the issue is that there is a missing quote, and you can you should be able to deduce this from some of the error messages. Now, suppose that you misspelled the name of a function, such as mySign. So in this case, the error message is a little bit less clear. It says mySign was not declared in this scope. So it's not saying it doesn't say you made a mistake. It's saying you have not yet declared this. Basically, the issue, however, is that the compiler does not know what mySign is, and it's not going to try to guess that you actually meant my_sign. Now, suppose that the function declaration and function definition don't match in the return type. Let's say you had double my sign double x, but then when you define the function, you accidentally wrote in int. The error message points out the ambiguity. It first says, oh, wait a second, there is a new declaration, int my sign taking a double, and it's pointing out the original old declaration, double my sign taking a double as an argument. It's even pointing out the lines. The issue is the contrast between line 15 and line 5 of your file. So the return type of the function declaration and the function definition must match. Now, suppose that the function declaration and definition don't match in the parameter types. So you'll recall that the function declaration had a parameter of type double, whereas if your definition has a parameter of type int, the error message is trying to say, look, inside main you are explicitly calling my sign with a double. You've also explicitly told me that there exists a version of my sign that takes double as an argument. The compiler, however, has not found any function definition where my sign has a double as an argument. There may be one here that has an int as a parameter, but not one that takes a double. So it's pointing out, look, I don't know where this function, my sign with a double, is defined. So basically, you've defined a new function, my sign taking an int, but the compiler is looking for my sign taking a double. Now, suppose that you accidentally use a single slash for a comment, such as here. Now, the error message is significantly less clear. And if you go through this, you start to understand what the issue is. The compiler is actually interpreting, or at least trying to interpret, the single slash as a division sign. And as you know, division is a binary operation, and therefore needs both a left and right operand. The first error message says, wait a second, I don't have a left operand. I need something before the slash. On top of that, what comes right after the slash is this, but this is an identifier that has not been declared in this function. So this was not declared in the scope of this function. Not only that, now it tries to interpret uses as well, and it's saying, well, wait a second, I have two identifiers, so I need either a semicolon or some sort of operation between this and uses. So again, it's a little bit more frustrating. By the way, please try not to write all your code and then comment all your code, because so often students will write all their code, it works, but then they add comments and they will on occasion put only a single slash, which means that the code that used to compile when submitted no longer compiles. So please put comments before, or if you must comment at the very end, at least run the compiler one more time before you submit. Now, suppose that you forget a closing parenthesis. So here there are two opening parentheses, but only one closing parenthesis. Basically, what it's saying here is, wait a second, I expect a closing parenthesis before the semicolon that terminates the statement. Alright, now it doesn't know where that closing parenthesis should actually go. It's just telling you, look, you desperately need a closing parenthesis before you finish this statement. Now, suppose you forgot an opening parenthesis. So here we see in a statement a single opening parenthesis but two closing parentheses. Well, this is a problem, as parentheses must match. Now, the error message suggests that the statement must finish before the next or the extra closing parenthesis. Now, the suggestion is wrong, but it didn't know that that's what you actually meant. So it's going on the best information it has, and if it sees an extra parenthesis, then it thinks you should have finished the previous statement before you started including another parenthesis. Suppose you forgot the asterisk in multiplication and instead simply used juxtaposition for multiplication. After all, this is something you did in secondary school. When you wrote xy, that was not interpreted as a single variable, but instead you automatically interpret that as x times y. However, the compiler does not do this. Instead, the error message says nothing about a missing asterisk. Instead, it says that the identifier XX was not declared in this scope. It's basically saying I have no clue what the identifier XX is. But at least it points it out, and you can then fix it. Now, suppose you forgot the asterisk symbol and instead used a space for multiplication. The error message is a little bit less helpful here. It seems to be trying to suggest you should be closing the arithmetic statement with a closing parenthesis first. So it's a little bit bizarre. It doesn't know what you actually meant here, so the error message is bizarre, but fortunately it still points you to the location where you can investigate the issue and then determine how to correctly fix it, even if its suggestion is nowhere near what the correct fix should be. Now, students often forget braces at the end of functions. The error message is very clear. Hey, at the end of this function, I expect a closing brace. It's suggesting the closing brace should appear at the end of the line. Well, where the closing brace appears really doesn't matter. All right, following this topic, you now understand that some mistakes lead to code that cannot be compiled. You understand that the compiler attempts to point out where the issue is, but sometimes it may be wrong. However, you also know that you should always try to fix the first compile time error. First, don't try to look at any other error, because fixing the first error may fix also all the subsequent errors. Here's the references, acknowledgments, colophon, and a disclaimer. Cheers!